Welcome everyone to the Distributed Summer 2020. My name's Dan. I'm the Executive Director for Distributed Compute Labs. I myself am a physicist, and so I use a lot of compute power for being able to discover stuff and plot propulsion in electromagnetic systems. But I, like many other people out there who need compute, whether it's for blockchain or scientific computing or artificial intelligence and what have you, I'm always looking for an easier way to deploy my applications. So in my case, it's scientific, and yours, well, we look forward to seeing what people end up hacking together this weekend. So in that vein, what we've done at Labs is produce a platform that allows developers with just a few lines of code to deploy applications across hundreds and hundreds of computers to harness their power to power their apps. And so I'd like to start, without further ado, right into a live demo. And then throughout the course of this meeting, we'll talk a little bit about the technology, we'll talk about the prizes, and we'll talk about how we're going to support you to come up with your cool app. And the coolest apps, of course, are going to win cash prizes on Judgment Day. So let me see if I can share my screen here successfully. And I'd like to show you what we mean by distributed computing. I'm just opening a simple browser tab here, and I'm going to a physics application right in the browser. So no download, no install. I can send this link to anywhere and anywhere, and they can just open it. Of course, I'm hotspotting, so it's both trying to transmit video and the site at the same time. And here we go. So if I scroll down, of course, we can make a website look like whatever we want in the browser version of this platform. And so this one, we made it look like a cool little scientific paper. And what I can do with this paper is build in my equations and explain the mathematics and so on and so forth. So for those of you who recognize what this is, it's pretty gory and ugly. But what's even worse is actually trying to compute some of these equations to produce the force curves that the scientists need to make their discoveries and publish publications and so on and so forth. But what's cool is that we've made it interactive, whereas instead of taking an afternoon to run this job, I can literally hit compute. It'll send the job up into the network, and then anybody with the worker tab open on their end, if they hit start, they are part of an instant distributed supercluster, and each of these people will suddenly be accepting tasks and computing them for the network, sending results back live to my screen. I'm not going to do this right now, but you can imagine what that's going to do. Essentially, we would use all of our computers on this call right now. Everyone would be participating in the computations, and then as soon as they're finished, all the plots would come back and populate my screen. So the idea of this hackathon is, what can you build? What could you build if you could launch a job that split up across 100 computers and was therefore completed 100 times faster, right? So that's what we're trying to build here. And we're looking forward to seeing what you're going to build over the weekend. So I'd like to use that as a segue to pass the floor over to Wes. He's the CTO and the mastermind behind a lot of technology, supported by an amazing team of expert developers for building this and making this possible, to explain a little bit more about what's under the hood. And we'll be doing some under the hood demos and giving people some ideas on what they can build. Wes, over to you.
Thank you, Dan. Welcome, hackathon participants. I can't tell you how excited I am to have you all trying out our platform and helping us to both test and prove the DCP platform at scale. DCP is a platform built on web technology. And by web technology, I mean both the technologies that are in the browser and the technologies that are in the browser and have been taken out of the browser for use in general purpose compute now, like Node.js. And we've taken those technologies and we've leveraged them to allow us to create a distributed compute platform. And like every distributed compute platform, essentially this is making an application that you run in one place that executes little pieces of itself in parallel on many other computers. How we represent these problems within the DCP framework is essentially that you make a JavaScript function that we call the work function, and you essentially get yourself a set of data that we call the input set, and you apply the input set to the work function with a function that we call job.exec. And that essentially does all the magic in the back end, sends it off to our scheduler. The scheduler sends it to all kinds of other computers, and the results come back. And the return value from the the resolved value of the promise that job.exec returns is a result set. So essentially, you take an input set, a function, and you get a result set out. At the end of the day, that's DCP at its absolute core. So we take care of a lot of the little details for you. But other than our few calls which do these things, you really have a fairly pure JavaScript development environment at your fingertips. We've got lots of bells and whistles and security components and Windows screensavers and lots of fancy things within the platform. For the duration of the hackathon, the majority of you will only be probably using 3 pieces of functionality, and that will be the portal. And the portal is where you manage your identity and bank account keys. You're going to be using the development framework itself to build a client application. So a client application is just an application that uses DCP. These applications can be built in either the web browser or in Node.js. And they can be tested or they can be run on the full network throughout the fullness of the hackathon. And when you do that, the hackathon participants will be running our worker in their own web browsers so that we can actually all connect together and become one large distributed computer to compute these workloads. And you can also do localized testing on your workloads just by changing your client program from using the function exec to using the function local exec. So you can see it's a very small change to go between local testing and deployment to the distributed computer at large. And from an architecture point of view, I think that's all that anybody really needs to know to get learning and digging. And there's all kinds of information in the Getting Started package that Parker and Topaz and team have put together for you. And you're also going to find that if you get confused by the tech, that we will have mentors online for you throughout the duration of the hackathon to give you a hand understanding concepts and getting unstuck if you're stuck. So make sure you take a look at the startup package to learn how to access that help. And I think that's about it. What do you think, Dan?
Sounds good to me. Let's just show some actual interesting applied demos, which is over to the demo team.
Sure, I can jump in here. Thanks, Dan. The demo I have today is an example of, hold on, let me share my screen. Oh, maybe loop back to me, Max. Not letting me share.
Let me see if I can go ahead and share my screen here.
Okay.
Can everybody see that?
You're not allowed to share. Topaz, do you have a control to allow Ryan to share? There we go.
I think I fixed it. I can share after.
Okay. Well, I will go ahead then. Can everybody hear me fine?
Yep.
Perfect. Okay, so the demo I'll be doing today is based off of a object detector API that's Google published a few months ago called Efficient.dat. So essentially, they've published as part of their AutoML library a essentially Python model from TensorFlow Python model, which performs object detection. I've converted this model into a JS model and then uploaded it to DCP using a TensorFlow JS tool that we provide. And basically what I'm going to be doing is using this object detection API, I'm going to be performing, object detection on an image. And what that image looks like is, let me see if I can share that image. Maybe I should just square the whole screen. There we go. Okay, so on this right here, you see this very grainy image of people in some sort of campus, right? And we're going to be doing basically object detection on that specific image. And I'm going to be demonstrating the DCP client's node entry point, basically. Ryan will be doing some browser stuff. But basically, I've initialized a node package here, and I've gone ahead and installed the required DCP packages, which is DCP clients. I've also gone ahead and thrown in some TensorFlow libraries for me to use. And basically, in my main function, I'm going to go ahead and require all the stuff that I need. And we're going to read this image file, this image right here, and we're going to convert it into a nice serializable object, which contains the data as an array and the shape of that image encoded in there. And one of the first things we're going to do is we're going to initialize DCP clients. Now, DCP client has a set of arguments that can be passed on to it so that we can sort of feed it which scheduler we want to pass it to, which ID key store we want to give it, which account key store we want to give it, that sort of stuff. And I'm going to go ahead and let DCP client here initialize with the arguments that I've passed to the function. Then we require the three sort of important stuff here: compute, wallet, and DCP CLI. DCP CLI is useful for creating, CLI based parsing using YARGs style options and that sort of thing. But compute and wallet are the important ones. Here we're going to get the identity key store, which I've gone ahead and put into my DCP directory. So that's the ID key store and the default doc key store. All of the docs will have all of the information on that. So don't worry too much about it. And I'm going to go ahead, add it to the wallets, and wait and get my account key store. And at that point, I've loaded all of the stuff I need to do the actual compute. Now, what's interesting is because this is based off of the object detection API that Google has, is it's been trained on a data set called COCO, which has about 90 or so classes of detections: people, bicycles, cars, motorcycles, a whole variety of stuff. And this here is the main work function. So we've got this compute.for. I pass it the parameters that I'm going to give, that are going to be distributed out. So this is an array. If I had, for example, multiple slices, I would be able to pass it an array that would be sliced up and given to all of the workers individually. Now, the slice info contains that .data and that .shape, which we then convert into a tensor, resize the tensor, and essentially perform our model inference on that tensor to get our results. I do a little bit of post-processing here in order to get around some of the confidence score issues and get better accurate results. And I just return that series of boxes. Now you can imagine this style of application being used with like a node server application or whatever, where clients can send off some video or some sorts, and you can slice up the video into a series of frames, distribute out the frames, collect results, and essentially return to your clients the video annotated with bounding boxes, labeling all the people and all the such objects inside of the scene. Now let's go ahead and actually see what this looks like. Or before I do that, actually, I did just want to touch on a few things here. So you'll notice that I require a few libraries inside of my compute.for. So specifically, I require tf.js, which is the TensorFlow.js library, as well as efficient.d0. Now, in order to be able to require inside of your worker function, you'll also need to require on your job, which means that over here, we have a job.requires, and as long as Node can find this specific module, we'll be able to side load it and ship it off with your worker function, and above you'll be able to use the same require syntax, and it'll all just work. Additionally, if you do want to use TensorFlow, I recommend you use this specific package, as it's one that we've tested and know works on DCP as of today. The other few things I want to touch on is this job.on. So you'll notice we have some events that we can catch and sort of relay back to you through the console. So when a job is accepted, we can do something here, or if a status is changed, or if you receive a result, or if you even just get a console message inside of your worker function, all of this is brought back to you through the job.on sort of event catcher. And lastly, one thing you might want to do is if you are doing some sort of job which requires you to use WebGL, or you need off-screen canvas in some way, we can actually set in the requirements environment off-screen canvas to true, and this will let the scheduler know that you want to require jobs that essentially have off-screen canvas available. This typically is what's used for the WebGL compute in TensorFlow. And finally, of course, like Wes was saying, we just use the job.exec with market value on the slices, and we provide our account key store and await that so that we can let it run to completion. Let's go ahead and see what that looks like. Now, first, I wanted to show this here. So if you wanted to see what all of the flags are that you can have with DCP CLI, and because of the init clients, you can do a -- help and a -- show hidden. It'll show you, all the little flags that you might want. And the important one here is we're going to be using the demo scheduler. So in order to do that, we're going to basically just okay. Perfect. So we're going to go ahead and just launch that. And this will run the whole distributed job. It will create a slice out of this image. We'll ship that off to DCP. We'll run TFJS using efficient debt model, and we'll get us the actual outputs here. You can see we got a few results, mainly people, it seems, although one umbrella. I have a doubt here that this umbrella actually exists, but I think we can see maybe over here, this person seems to be holding something. So perhaps the network, because of the graininess of the image, saw this and figured it was an umbrella. I can see why I got confused there. But otherwise, we can see that we have people, boxes, locations for those boxes, and confidence scores for each of the classes. And that's how you distribute a TensorFlow.js model on DCP and perform object detection quite easily and quite cheaply. I'll pass it along to Ryan to share a demo.
Great, thanks, Hamada. That was really cool.
Sure.
So the demo I have, I built a few months ago to test if we can use WebGL to render things on the distributed network. So the demo I built is this distributed fractals example. And what this does is it's a job that contains some code for running shaders using WebGL, and then it will render a frame and return that back to the client. So I'll just go ahead and run this. It's a web application, so I have a little web server here. If I boot up localhost, we have our page. And if I go ahead and hit go and provide it my key store, this is our DCP client modal. So it'll prompt you for a key store, which you can provide. It'll ask you for your password. Nope, that one. And then you'll see on the side we've received a status message. This is coming from one of those .on events that Hamada was explaining. So you can see we have one slice. It hasn't been distributed yet. So it'll take a quick second for it to be received by one of our workers. In the meantime, I'll go through the code a little bit because there are a few differences between our Node.js client and our web clients. So Hamada was explaining how you can provide some command line options to override the key stores, which it'll look for in your .dcp folder. So I have those as well. I have key stores in .dcp, but since it's running from the browser, oh, there we go. We got our fractal back. So this was rendered on someone else's computer in the browser using WebGL. Now, web DCP clients can't access your disk directly. So it can't use these key stores you have in your home directory. So that's why we have to prompt for your bank key store. But the identity key store is a little bit different. That's done just by providing your ID key store right next to wherever file you're loading. So if we were to like look in the network, we saw that it requested that ID key store for knowing what to use as our identity. And the rest of it is fairly similar to how Hamada had his setup. Instead of relying on Node.js packing our dependencies, I'm using Webpack to bundle up our work function with all the dependencies. So whatever we require here gets bundled into a Webpack bundle, and then we just load that as a string. So you can provide a string to your data compute.for, and it'll try and run that as a function. So that's why I'm wrapping it like this. It'll just run this function, and then I can pull in whatever I want from my Webpack. And then once we run the job, we wait for the results. So wait for it to be rendered. And then we recreate the image based on the raw pixel data we got back from that client. And that's the gist of it. You get nice fractals, and you could distribute this. Right now we're running one slice, but you could split this image up to make it like tens of thousands of pixels wide and tall, and then split this up into like 1,000 pixel each sections. Because rendering's easily distributable like that. That's it for me. On to whoever's next.
Awesome. Thanks, Ryan. So I'm going to be running through basically the entire setup and how to get started with launching your first DCP job. Our examples and trial runs are going to be a lot less impressive than Ryan and Hamada's, but they'll show you the gist of the platform and basically show you how to make some really cool projects this weekend. So I'm curious to see how many people in the audience are interested in actually running through the demo and getting set up with me right now. You can just type in chat, or let's say here.
Yeah, I am.
Awesome, cool, okay. So I'll try and run through slow enough that we can go step by step. And if you have any questions, please don't hesitate to ask, because we're all learning here. So to get started, I want to direct you guys to dcp.dev in your browser.
Want to share your screen?
Yep.
That's fine. Let's do the whole desktop.
Where is it?
It's already selected. You just hit share.
So you probably got a link to this site in the PDF that Topaz sent out earlier. She indicated a lot of necessary steps for this hackathon. So if you're ready to go, let's just get started. So on this website, we have a link to our developer guide, and that is the first thing you're going to want to press. From here, we have a nice introduction saying, welcome to DCP. And one caveat is that we want to kind of outline this little part here. We're currently in our beta stages right now, and we've invited developers to come and try it out. You guys at the hackathon are actually a really cool exception, meaning you have access just like the first beta testers to our platform. So please just disregard this message. And if any of your friends are asking during the hackathon, like, oh, what does this mean? Just let them know that you're free to go. Other than that, we have our tutorials, quick start guide, really fast, just gets you right into it. The developer guide is what you're going to want to click on, and it's going to walk you through step by step, basically how to get started with this whole platform. Cool. So overview, basically how we get started with DCP is you have to make an account on our portal. And as part of the hackathon this weekend, you guys are given special access on the portal, meaning that as soon as you sign up between now and the end of Sunday, we give you guys special access to deploy jobs to the network, as well as some distributed compute credits in order to actually deploy jobs and pay for the work that other people are doing. So that's the first step. We have to make an account. Next one, we're going to be setting up our key stores on your computer so that when you're trying to launch jobs, everything works properly. After that, we're going to set up the development environment. If you're familiar with vanilla web, just using JavaScript on the browser, we're going to do that, as well as Node if anybody's interested. I know, Will, you were talking about that. So we'll check that out. And after that, we'll just get started and deploy our first job. Really simple job, but you'll be able to make your own cool ones from there. So let's just jump right in. So I will make an account on the portal here. There you go. So just click register and should send me a verification code. Oh, not secure. Cool. So I'm going to go check my email and type in the verification code.
You not know your Gmail password? You could log in on this.
I can.
It's your call.
I'll do it. I'll do it.
I might just explain to the audience at home that Parker's borrowing my laptop, and so he doesn't have access to his Gmail on the laptop. So he's typing in the code. But of course, in your email, you get a link, and you can click on the link.
Hmm. Cool.
Oh, nice typing.
Oh, okay. So we're signed into the portal. And one thing that we have running right now is that special script that gives you access to credits and deploying. And if you check your accounts page right now in the portal, you might notice that you don't have anything yet. It takes a few minutes to get up and running. So just don't worry about that. It'll pop up in a couple minutes and we'll check that. But for right now, I just want to give you a quick tour of the portal, because this is where you access a lot of the necessary aspects of DCP. So the first one I wanted to show you, which is here in the tutorial, is the worker tab. This is the heart of what's going on with DCP. This is the worker. And from right here, you can open it up, press start, and your computer will start computing slices of work that are being distributed across the network. Right here, you can see Electrodynamics at home is currently deployed a job on the network. And right now on Casey's laptop, we're computing slices of work, which is pretty awesome. You'll also notice once one of these actually finishes that this little spot right here shows you how many distributed compute credits you actually earned for doing that work. And distributed compute credits is what you're going to be using to deploy your jobs, because you have to pay the other people for the work they did. Actually, I'll actually let that finish so you can see it kind of pop up. There you go. So you can see the little amount of credits that we earn for each slice that we complete, which is pretty cool.
Now, just a question. Are those credits Bitcoin? Are they redeemable for money?
Not currently, but that is the plan for the future, I believe. Yep.
You should stop as soon as you unplug the battery.
That's awesome.
Cool. So next I'll show you the profile page. This is where you can put in some of your information. Well, it's also the location where you're going to be retrieving your identity key store, which is unique to you. And it basically just tells the scheduler that you deployed this job. And so we can kind of trace back who's doing which work on the network, which is pretty cool. Next is the accounts page. And this is pretty important because it lists all of the bank accounts that you have with DCP. And in a moment here, when we refresh the page, we should see the one pop up that already has 25 credits in it. But one key thing is that the work we just did for this default bank account, you can see that right here, which is pretty cool. So what I'm going to do now is refresh the page, and hopefully we should have been given special access. Oh no, really? Okay, well,
Yeah, if I refresh, will I get special access too?
if you just signed up, you should have been given special access. It might take a few minutes to pop up, but yeah.
No, it was an older account.
No. If you've already made an account, I don't believe you've been given special access since we've kind of enabled
signed
this.
up since like 2 today.
Yeah, since about 2 o'clock today is when we kind of turned on that ability. So new hackathon participants can kind of get it during this weekend.
Okay, I'll just create a new account.
Perfect. Thank you.
Yeah, you might need to sign into your email. Yeah, I wouldn't do that.
Okay. Try and sign in again.
You can't even hear forgot password. Just
There you go. I can actually copy this time. That's
you can
nice.
also just hit reset password.
Cool. Okay. Just sign back in, check my account, and you can see the August 2020 hackathon account has popped up, which is great. So that now means I have some nice credits to spend, as well as I now have the ability to deploy my jobs on the network. So that's great. And we can move on with the tutorial. So step 2, you're all signed up. Now you need to download and set up your key stores. And starting with the bank key store, you're going to want to navigate to the accounts tab in the portal and navigate to specifically, you're most likely going to be wanting to use the key store we gave some credits on it. So I'm just going to click the little drop down arrow, press download. You can see it, it already gave it a name. And one thing I might want to do is actually change the name to default.keystore because that's the default name that it looks for.
Yeah, we'll need to move it to .dcp, huh?
Yep, not yet.
Are you gonna do that later?
Yep.
Okay.
So once we've downloaded the bank key store, this is the one that will be having credits taken out of it as we deploy jobs from the web or Node or whatever you're using. And next is downloading the ID key store specific to you. And in order to do that, it's located on the profile page, kind of near the bottom. There you are. So if you want to create a new ID key store called provisioning, just click the little green button there, name it whatever you want. And there you go. And now I should be able to download this key store and give it a password if I'd like. And if you don't want a password, just for convenience sake, during the hackathon, wanting to deploy a lot of jobs, don't have to. And so I'm just not going to. And you can see it saved that as id.keystore into my downloads folder, which is good. You can see in here, it does say we recommend naming ID key store because that's the default name that the DCP kind of searches for when it's looking for your key stores. And after that, we're going to want to actually move the key stores into a location on our computer that DCP looks for. And that differs depending on your computer. So if you're on Windows, which I'm sure a lot of you will be, The default location that we kind of search for is in C users, your username, and then .dcp. And if you notice that that's not already there, which it shouldn't be, you're gonna have to create the directory and then copy those files in there. And on macOS and Linux, it's located in the home directory. This is a bit of a typo. You just want to put it in the ~key /.dcp, which you will also have to make. And so we're going to do that now. Try and get this away. Yeah, there you go. Cool. So I'm going to be using the terminal for this because I find it easier, but if you like just dragging and dropping the files around, that's good too. So I'm going to make a directory called .dcp in my home tilde directory. And then I'm going to want to move my id.keystore from my downloads into my .dcp folder. I'm going to do the same with my default key store. Cool. So now if I navigate into my .dcp folder I made, list the files there, I should see these two, which is super important for node projects. If you're doing vanilla web projects, it won't actually look here. You get to kind of pick the bank key store you use, and your ID key store has to be kind of sitting in the web folder. So I'm just going to download another version of my ID key store. So I have two. Cool. And that's it. So now the key stores are set up and we're ready to actually start getting our development environment set up. So Will, I remember you said you were familiar with Node.
Yep.
I'm sure some of you are familiar with vanilla web development, maybe both. I'm going to run through both. If you don't feel like doing the Node one, just kind of watch and wait. I'm going to cover the vanilla web one right after. So I just want to go through both in case someone's interested. So first of all, so the latest version of Node. Second of all, you're going to want to make a new project and make sure it's got a package.json file. So I'm going to make a new project. And I'm going to run npm init to make that package.json. Let's give it the default names and everything. Cool. So now you can see package.json was made, and this kind of gets us ready to actually start doing npm install DCP client, which is the entry point to everything DCP, which is pretty exciting. So DCP client, and then just go and grab DCP client from npm's repository of packages. And for anybody who hasn't used Node before, hopefully this example can kind of just show you how easy it is to get up and running with JavaScript out of the browser. So if you've never touched it before, this is actually a pretty good place to learn, I think.
Yeah, I might need to help you out there on my computer because I use a version manager that confuses what's it called, Node.jip, and can't figure out which Python to use. Sorry.
All good.
Let's try that again. So I just have to tell it for this shell session to use Python 2.
Okay.
Otherwise, it asks ASDF which Python to use, and it grabs the wrong one. I don't know why. That's an ASDF thing. There you go.
Okay. Just want to check in for whoever's following along. Am I going a bit too fast or right speed? Let me know if you're still just waiting on stuff to install.
I have a question. Do the key stores, I have to move 2 of them to the DCP directory. Is it, I downloaded the default key store. Is the other key store that I want the August 2020 Hackathon key store?
One of them is the bank key store, which we renamed to default. And that was the one I downloaded was the August Hackathon.
Okay, but we want them both in that DCP directory?
Yeah.
Okay, all right, very good, thank you. And
Yeah,
do
no
I want to rename the August 20 to ID, that key store?
You want to rename the August 2020 Hackathon one to default.keystore.
Ah.
That is the current default name of bank key stores that we look for.
Very good, thank you.
Yeah, no problem. Cool. So depending on which development environment you like to use, we're just going to use VS Code here. And I can launch that quickly from the terminal. Cool. So you can see basically empty node project, as simple as it gets. We npm install DCP client, and we're basically ready to go and start making some node files. So I'm going to make one just called index.js. Cool. And that's all the steps you need to get ready with making your node project. We'll run through some examples actually. And if you're curious right now to actually check one out, we have a node exemplar, which is a good first example for launching your first node application. Actually, if you guys want, let me know. Did you want me to go through that example right now?
Sure.
Cool. Okay. So this is a GitHub repository we have. And I'm just going to clone this one. It's basically exactly what we just did. It's got a package installed DCP client with just a pretty basic JavaScript file. So I'll clone that. Cool. So this is an example Wes actually made, and it runs through a lot of the basic functionality of DCP and kind of outlines just how simple it is to launch your first job. So open it up here. We have a main function, asynchronous, which allows us to use a wait, which is pretty nice. And just like in Hamada's example and in Ryan's example, you can see we require the compute module from DCP. We also require the wallet module, which helps with specifying where the wallet should be. And right here is our job that we want to deploy into the network. So you can see here our input set is a very basic input set. It's not an image of tensors. It's an array of colors. And what we can do is next argument is provided the work function, which takes in a color, each one of these values, logs it, and returns it. And that's it. That's the job that we want to kind of split up and deploy across hundreds of computers. And after that, we have our events, kind of just lets us know, like if the job's accepted, print that. Once the job's complete, print that. If there's any state change during the job, print that. And the result. You can also print the result. These here are setting like the public name of your job. So if you remember back in the worker tab, you can see electrodynamics at home. It's kind of similar. It just tells you the name of the job that's going on, so you know what you're computing, which is pretty neat. You might actually notice during the hackathon, like other hackers' jobs popping up on your worker, and you're actually computing for the other hackers, which will be pretty interesting. Other than that, we are manually loading the wallet key store, going like let key store equal wallet.get from the DCP module. And as you can see here, it loads it from right there, which is what we did in the previous step. After that, we launch our job.exec. We basically just tell it like compute at market value. I don't want to charge any more or less for this job. I just want it to be the regular market value of distributed compute credits. And that's about it. You can see that if I run this, hello, I lost it. Here you go. Okay. I think I totally just closed the window there.
try and do?
There you go. I'm struggling on this MacBook, by the way. Oh, yeah, that's a good point.
And you
And-
need to do the Python thing again for the shell. Right, well, I guess you never closed the other one, yeah?
No, I never did.
Okay. So it'll use the same Python,
Mhm.
same Python rule.
Yeah, I forgot to npmi on this one. It's a new project I made. Cool. So now I'll just run the file and you'll see all the code that Wes typed in. It'll launch the job and we'll see the status as it goes.
I think you want to send this to the deploy to the demo scheduler.
I should have access.
Yeah, that's right. That's right. Learn setup. You should.
Interesting. As a learning experience, this error here that we got saying role deploy is required, basically just says that you haven't been added to the special deploy list. That's probably just an issue we have with the setup on this laptop, but as a fresh install with a fresh account, which you guys will have, it'll just deploy it and you'll see all these event callbacks kind of spit out as the job gets deployed across the network. That was a fairly quick overview, but a bit of a simple example of launching our first job in Node. Yeah. Continuing on to vanilla web, if anybody's interested on using it like that. The setup for this is actually even quicker than using Node, which is pretty exciting. You can also add it on to any existing web project you have and distribute compute across our network, which is pretty cool. So in order to gain access to all the good DCP kind of flavored code that we have into your project, all you have to do is add this little script tag to the top of your HTML file. And if you've never used HTML, you've never done web development or JavaScript before, don't worry, we have a bunch of different examples to kind of get you started. And it's a pretty good place to start learning. So for example, here, we have a quick demo, which I will open. It's just on JS Fiddle, a good spot to kind of show off quick web projects. And you can see here, here's our HTML file, index.html. You can see at the top, we imported the script for the scheduler, and it kind of grabs DCP client, gets everything ready so you can use it on your project. Rest of the HTML is just like super basic button with some text kind of telling you what to do for people who aren't in this workshop. And right here is all the JavaScript you need to launch a super, super simple job on the network. This at the top is what gets the compute module from DCP client, which allows you to do job equals compute.do, compute.for, things like that. And other than that, all I did was get a button that tells you to kind of launch this job whenever you click it. And here it is. Here's all the code. So job equals compute.do 10. What this basically does is it feeds in 0 to 9 as the inputs to this work function. And all the work function does right now, maybe you wouldn't really need to distribute this one, but it's just I times 10. So it's going to go 0 times 10, 1 times 10, 2 times 10, and it might split that up into 10 different computers and they're all going to compute it. And I just have some super simple events. I listen for console if I ever wanted to put a console.log in here. I listen for when the job gets accepted to let me know. And I listen for when it gets complete. And I print some results. And just like before, I gave my job a public name. public description, and otherwise I should be good to go. Cool. Oh, this is so tiny. So it's prompting me to pick my key store, and this might be a little bit vague, but it's prompting me to pick my bank key store, the one that it will take credits out of as I deploy the job. So I'm going to go ahead and
I don't want to make your invisible files visible if it's sitting there. And then pick your bank key store.
Yep. Now, since I made an account using an email that I believe already existed, potentially, it might give me that deploy error again. We're not too sure, but let me know if you guys are able to do this and it deploys okay. Bit of a quick test run before the hackathon starts in case we need to iron out any other issues. Yeah, okay, so same issue.
Yeah, and I'd just like to mention that actually for the hackathon, we have a scheduler, our demo scheduler, which we're planning on having folks use because then it's not mixed in with the traffic over on the main scheduler. So that'll be a nice place to work from, and it actually doesn't require ID key store. Like you'll have permission on the main network, which is cool, but it won't be required. So I think if we run this again, we can give this another go. Oh, I gotta resize this.
You might push minimize there.
Try that again. I'll get it remembered.
It's the bank key store.
No.
There you go. Default.
Default. That's the bank one.
And yeah,
Now we can
if you
bring this
open up the
console
console,
back
you
up.
should see the logs basically accepted our job. We don't really pop anything out until the job's done, but there's a list of the results that got computed by.
And when you see the docs, there are actually a bunch of events besides these ones. You can get an event on every result and all status events and all kinds of things to get a better idea of what's going on as well.
Yeah, there's a lot you can do. We just really wanted to give you a nice bite-sized piece to start, so it wasn't a little bit too daunting as you first started. But
That's right.
Just using an HTML file and a JavaScript script that's 40 lines long, not even, you can deploy a task onto the network, which is pretty cool. This next part, deploying jobs, is basically what we just went through with these demos, but we wanted to give you guys a bunch of different examples and a bunch of different use cases to kind of inspire you to make your own functions for work. So in this one, we just do job equals compute.for, gives us a range of 1 to 10, and it uses that range of 1 to 10 as inputs to this. It just goes n plus 100. It calls progress, which is actually really important within a work function. And there's a little bit more on that later in the docs. But if you wanted me to just go over it now, it's something that you have to call in your work function basically to just let it know that it is progressing. And if you don't, it'll spit out a little error saying it's not progressing and kind of cancel that job. Yeah, and so all this does, it goes n plus 100, result times n, and then spits it out. And that's the entire function. And it's pretty basic, but you can kind of see how this can get split up and split across many different computers. And in the same vein, in vanilla web rather than Node, you can see it's basically the same exact structure aside from importing compute from DCP client is just a little bit different up at the top. This one, all it does is split the job up into red, green, and blue and log the color like we saw before. And a word of advice, this was also mentioned in the PDF. As you're deploying jobs, it actually costs you credits to deploy jobs. And if you don't want to be deploying credits or deploying massive jobs that you don't know work, we have something called local exec. And what local exec does is instead of typing exec here, you can do local exec, and that will run the job on your own computer without costing you any credits at all, which is a great way of testing. If you're a researcher and you had this really complex task that you wanted to put on the network, that would cost you hundreds of DCs, and that's all you got. You wouldn't want to put out a task that you didn't know worked. So that's kind of the intention of local exec. And we expect that if you guys want to get a lot of tasks done, get them done quickly, and make sure it's not costing you a bunch of stuff throughout the weekend. Just
it's also good for debugging, because the work function, instead of getting sent to some other computer you can't see, it gets sent to your computer. It uses the same schedule, uses all the same connectivity. You have to have an internet connection. So it's really the same as the real job, but it's going to send to your own device. And so you'll be able to inspect that process. And you know, if you're on the web, you'll be able to use Chrome's debugging tools, for example, and see what's actually going on inside.
Mm-hmm. Cool. So pretty much the last few steps of this tutorial just kind of outlines the ramifications of deploying jobs. So every time you deploy a job, it costs you some DCCs. And you'll actually notice, like, if I try launching a job and it succeeds, I can actually go into my portal and see that my DCC balance went down. So it went down from 25 DCC to 24 point something. And you might want to watch that throughout the weekend. I don't know if you'd be deploying enough to really run it that low, but definitely something to look out for. Here's just a quick list of some of the events you can listen to, as we did in our example here. Console accepted complete. You can see the list is right here. And there's definitely some other ones as well. It's in the documentation. And after that, we just gave you a big list of examples just so you can kind of see where our head was at when we gave you all the access to all these functions. So, you know, it's logging things, it's just printing hello world. This one catches an error, all pretty helpful listeners. So, and lastly, we just wanted to outline a couple of the different modules that you have access to. You probably would have noticed in Hamada and Ryan's example that they were using things like DCP CLI or Wallet. And these give you a lot of extra tools to kind of interact with DCP how you want, rather than the default behavior in a lot of these examples here. So there's plenty of documentation you can see here on how to use these and what methods you have access to when you're using them. So if you're ever looking for a more in-depth control of what you can do on DCP, we're going to prompt you to kind of go to the documentation throughout the weekend. And lastly, we currently support WebGL. If you want to do tasks like that, if you're looking to read more about how to deploy jobs for GPU, read here. I don't know if you really can right now. Can?
Yeah, cool.
Okay.
For some of them.
Yeah. Other than that, that's it for this entire tutorial to kind of get you up and running. And we're hoping by now that you have an okay enough sense that you could kind of look through our documentation and start trying to figure out how to launch some really cool distributed jobs. So does anybody have any questions?
Oh, hi. This is a little unrelated, but my colleague Raphael was running the DCP worker, and he said he was only running it for about 10 minutes, but he earned 0.003 credits with a total computing time of 1.5 hours. So how would that work out? Does that mean that job that we would have enough credits to run a job for 1.5 hours? That seems like a lot just for 10 minutes of computing, or how does that work out?
So he must have a lot of cores on that machine. That's actually the sum total wall clock time of compute that was computed in the worker during the time it was running for each core. So if each core ran for 1 minute, then you've done 10 compute minutes worth of work. Whether that's enough to do 10 cores worth of work on the network with the same credits sort of depends on a few things, but the long answer is pretty much. The short answer is during the hackathon, the slices are fixed price per slice. I put together a document actually that I'll link shortly that it goes into that a little bit for those of you who are curious, so that essentially every slice that gets computed during the hackathon will be computed at the same price. So don't worry too much about the compute hours that you see in that particular display, I guess is the takeaway from that.
All right, thanks.
Cool. So other than that, that was it for me in terms of the intro tutorial. And I just have one last question. Did anybody try launching a job and have no problem? Did it give you the error, or were you able to just send it off?
I was fine. You mean the events example? That ran to completion. It's fine.
Awesome. That's good news. Okay. It's definitely just on my end then. Hopefully everyone else's is all right. Yep. So that's it for me.
Any other questions for anyone?
Sure. Do you have any recommendations for what should we think of when we're coming up with our own projects? I know there was a fractal example and a machine learning example with TensorFlow JS. Do you have any other kind of avenues that we should think about when we're thinking about a project to work on for this weekend?
My personal advice is to think of something that you think is cool. One of the things that I love about being a platform developer is that people use my stuff to do things that I will never ever think of, which is why I don't like telling people what they should do with it. That said, DCP right now is limited to solving perfectly parallel problems. So if that means something to you, then that's great. If not, hit Google or ask Dan to give you the laundry list of the types of problems that solves. But really, I would absolutely encourage you guys to be as creative as possible. And even though we've shown you some pretty cool things that can be done, do stuff that you think is cool.
Sounds great. Thanks, Wes.
Yeah, personally, I'm going to go on to Shader Toy, try to find a really cool shader to distribute, something like a fractal, or there's so many shaders out there that I think, would look very, very cool being rendered.
That's awesome, Dom. Well, thanks all. Good luck with the hacks, and we're excited to see what gets surprised. I mean, I personally would probably do some distributed genetic code searches and stuff like that, but that's just me. Topaz, you want to have the closing final word?
Sure. So yeah, super excited to see what you build tomorrow. I believe if you were here, you all received my emails and now you are up and running. If you haven't formed your groups yet, I know some of you have, please think about or post on Discord, because there's plenty of people that are looking for teams. And I think that's it from us.
All right. Have a great evening. Bye-bye.
Bye, everyone.